Alright, students, in this video, we're going to go over the notes of solving systems, 3x3 systems, with simple substitution. So this is the Algebra 2 version of solving systems with substitution, but instead of two equations, the Algebra 1 level, now we're doing the Algebra 2 level, which is 3x3 systems. So a couple things to understand. Sometimes the three equations are written easily for you to solve with substitution, and sometimes they're not. So for example, this one has one variable on this equation, and it can easily be solved. Then you have this other example where this third equation is already written y equals, and this other one has more steps to it. So these two right here are like a mini version of the Algebra 1 level. So here's again the example of the equations we were doing in Algebra 1. And it's these two that create that system and could be solved applying that. So it's still another easy way to solve with substitution. So two equations form a 2x2 system. So these two examples are actually very efficient when it comes to deciding whether to solve using the substitution method or not. There are other methods that we're going to learn solving 3x3 systems, but in this example, these two setups are very efficient for substitution. The third example is an example of what is not efficient. And the reason why, it's because you have all three equations with all three variables. So there'll be other methods that could be used to solve for the solution for the system when all three variables exist. We'll learn those in future. Okay, so since we decide that these are very efficient, you want to learn in what order to solve. So here's an example. You want to set the simplest equation first. So that's your first equation to solve for because that's the simplest. This will result in giving you the answer for z. And then you're going to use that value of z and substitute the equation into another simplest equation after that. So between these two, this second equation right here, that would be the second equation to use. You'll substitute the value of z in there, and then you'll solve for y. And then you will substitute the known variables that you already found into the last remaining equation. So this will be the last equation to solve for, because now you only need to solve for the remaining missing value. So we already have the z, we already have the y, and now we're going to be solving for x. And once you solve for x, then you have all three variables, but you have to write the solution in this order: x, y, z. So after this, make sure you guys rewrite in the order of x, y, and z. And that will be your solution. Okay, so let's go over a couple of examples. The first example and the second example are both similar. They both have an equation that is super easy to solve for right away. They both have a middle equation that is easy to solve for once you find that other variable. And the third one's similar. So we're just going to go over one of these examples since they're very similar, and then we'll do this last one. So the first one, it has 2z equals 8. You want to solve for the simplest form between these three. This is the easiest, so we're going to do this first. And then we just divide by 2, so z equals 4. In our solution, we're going to have x, y, z, and we already have z. So now we look at the equations and we're like, oh, the middle equation uses z to find y. So we're going to use that middle equation and solve for y. We're going to replace the value of z in here. So we're going to substitute a 4 in there. Y plus 2 times 4 equals 6. So 2 times 4 is 8. Subtract 8. And y equals -2. So now we have the y value. And then now the last part is using this y and z value on that last equation to substitute each letter. So we have 2x minus y plus 5z equals 24. And we're going to substitute the y with a -2. So we're going to copy 2x minus times -2 plus 5. And then we substitute the z in there, which was a 4. And that equals 24. So this equation, we just need to simplify and solve for x. So negative times negative is positive. So 2x plus 2. 5 times 4 is 20. And then we combine like terms. 2 plus 20, that's 22. And then now we solve. So we move the 22 to the other side. So 2x equals 2. And then we divide. X equals 1. So the answer here is 1, -2, and 4 as a solution for the system. Okay? Notice that on the second problem, the order of the equations seems different. So it's not going to be last, second, first. You're going to look for the simplest one of all of them. The top one seems to be the first because it's the easiest. That will give you your x value. So let's just do it real quick. Divide, and x equals 8. So just like that, our ordered triple has an x, y, and z, but so far we have the x. Then you use that x for the second most efficient. So between the other two, the second one can give you the answer. So 2x plus 3y equals 10. We're going to substitute the x with an 8. And then we solve. So 2 times 8 is 16. And then we subtract. And 3y equals -6. And then divide by 3. So y equals -2. So y equals -2. X equals 8. And then the z is using the one that has all of them. X plus y minus 2z equals 22. And the x is replaced with 8, because that's what we got for x. And we're going to add what we got for y. So that is a -2. And then we subtract 2z, and that equals 22. So simplify this. We have 8 plus -2. 8 plus -2 is 6. Minus 2z equals 22. We're solving for z, so we subtract 6. -2z equals 18. No, actually 16, sorry. 22 minus 6, 16. And then we divide by -2. So z equals -8. All right, so then now we have the solution for this system. And you can use the skill we practiced in class to verify solutions, which was this, just plugging in and checking. And these should all be true for all three. All right, the last example would be this one that does not have an easy equation just by looking at it. However, we notice that this y is by itself, and we can use that. We can ignore the top equation and focus on these two and apply the skills from Algebra 1. So we're going to write the equation that has the y by itself, and we're going to isolate for y. So that means this negative 3x needs to go to the other side. We're going to add 3x, cancels, and we end up with 6 plus 3x. These are not like terms, so we're going to add them. We don't get 9x, we just get 6 plus 3x. And then after that, we're going to substitute this expression in for the letter y on this other equation right here. So ignore the top one for now. So we're going to write 7x minus 3y equals negative 14. And then for the y, we're going to substitute this expression. So 7x minus 3, parentheses, 6 plus 3x equals negative 14. And then we're going to now simplify and solve for x. So 7x comes down. Negative 3 times 6 is negative 18. Negative 3 times positive 3 is negative 9x. And then equals negative 14. So distribute, combine like terms. Like terms are these two. So 7 minus 9 is negative 2. Okay, so those two combine to be negative 2. The 18 comes down. And then we keep solving. We are going to move the 18 to the other side. And negative 2x equals 4. We're going to divide by negative 2. And x equals negative 2. So all that work, and we only found so far one of the values. X, y, z. And so far we only found x. But that's okay, because now that we have it, we're just going to plug it in here and solve for the other letters. So we go back to using that x to find the y. You pick one of these. The easiest to use will be the bottom equation. So we're going to use, I'm just going to draw a line right here. Negative 3x plus y equals 6. We're going to substitute this x value in for x. So negative 3 times negative 2 plus y equals 6. And then we're going to solve. So negative times negative is positive. 3 times 2 is 6. And then right here, 6 plus y equals 6. So that means y is nothing. So the way we algebraically do it is by moving the 6 over. And y equals 0. So that means on our solution, y equals 0. Okay, I know we're running out of space, but let's quickly do z. So now that we have x and y, we're going to use the top equation that has the z, and we're going to substitute those values of x and y. X plus 3y minus 4z equals negative 34. So then here, let me zoom in. We're going to substitute the x with negative 2 plus 3 times the y of 0 minus 4z equals negative 34. And then negative 2, 3 times 0 is 0, so this cancels. Negative 4z equals negative 34. We're solving for z, so this negative 2 has to go to the other side. So we're going to add 2. And we're left with negative 4z equals negative 32. And then divide by negative 4. So z equals positive 8. Okay? So then we have 8. All right, so that is 3 examples, or there are 3 examples of how to solve a 3x3 system using the substitution method. And again, you could pause, rewind, or rewatch as much as you need. Hope this video helped you.